Hi everyone. Apologies for last week. I decided to leave all my assignments to the last minute, as I'm usually pretty good at doing. So I think, as I alluded to in that email, I'm going to slightly change it up a little bit. We're going to make this into a sequence of probably 15 or 16, 35 to 40-minute recordings. I just think, yeah, maybe 8 to 9 p.m. doing math methods was probably a little bit ambitious, mostly for me to start teaching at 8 in the morning. So the brain's a bit fried. I think 40 minutes is probably easier. And what I'm going to do is we'll go back probably to the 10A side of things for this one. And I'm going to make a sequence that's going to start, and I'll number them sort of, and then we'll move all the way up to the end of the unit. Henry, you're doing grade 11 method. Sorry?
Yeah, I am.
Yeah, so you'll be coming to the end of unit 2 now, wouldn't you? Be getting ready to start unit 4 next term.
Yep.
So I'm going to probably be a little bit jumbled up for the next few weeks, going back to 10A, and then we'll work forward to the end of unit 2. Probably over 15 or 16 recordings. There'll be 2 this week, maybe 3 next week. I've got a fair bit of spare time next week. Being week 10, I don't have to do any planning or anything. So, and then a couple of extras in the holidays to make it up to like 10 hours worth of recordings, probably a little bit more. I said a problem last week. It kind of pertains to what we're doing. What I find, especially in 10A and 11 methods, is that most students' algebra skills are not up to scratch. Henry, what science subjects are you doing next year?
I'm doing physics and chemistry, I think.
So you will not use math methods in high school chemistry or physics. You'll use it in university physics. You won't really use it in chemistry. Depending on what you want to do, some of your theoretical chem, it might be worth doing. To go into medicine, again, you're not going to use math methods at all. I don't know why it's a prerequisite anymore. And algebra skills tend to be really lacking, is what I find. So again, we've kind of gone back to the beginning on this one. So we were talking about interest last week or the week before. Our compound interest formula is A equals P, or the principal, 1 plus I n. We went through rearranging to solve the others, but the interest is the more complicated one. So I'm not even gonna put numbers into it. Actually, I will. So $9,500 invested at so 9,500 is A. P is 8,300. And we've got N is 8. But what I don't know is what interest rate do I need to end up with $9,500 after 2 years with 8 compounding periods when I start with 8,300. So the very first thing you do, and in order to get the marks, you need to write out the formula. You might use a slightly different formula depending on your teacher and if you're in grade 10 or 11. So we'd end up with A being 9,500. That's 8,000 equals 8,300. 1 plus I to the power of. Now, it's a little bit tricky because we're now looking at to the power of. But what's the inverse of power of, Henry? The eighth root, yeah. So we need to solve for this. And again, the amount I've been dealing with a lot of university chemistry and physics students, and they just can't do algebra. And I feel like if you're doing methods, then you're going to be doing science. So this ties in quite well. This will probably be like the second video in the sequence of the whole thing. So we want to put, we would then have 1 plus I to the power of 8. If we've swapped these two, what do we have to do to the 8,300?
Square root.
So we've still kept it as to the power of.
Oh. Oh, we just do 9,500 divided by 8,300.
Perfect. What's your calculator say that equals? I'm going to say 1.4 something.
Right, I'll just get my calculator.
What fins here? Sorry, I didn't see it.
Yeah, it's like 1.14.
Hey, Finn.
How you going, Liam?
Good, how are you?
Yeah, not bad.
So just finishing off that interest problem we left on, not last week, the week before, or last Monday. I was just explaining to Henry and everyone watching the recording that I'm probably going to make this like a sequence of like 15 videos, like 35 to 40 minutes each, starting at 10A and then progressing through to the end of unit 2 of year 11. So we're going to go backwards a little bit. What science subjects are you doing next year, Finn?
Sorry, Liam, what was that?
What science subjects are you doing?
I'm doing chemistry, chemistry or marine something. What it is? Marine.
So yeah.
I think that's it. Just chemistry and marine.
Yeah. So I'm trying to make it so that this is related to the sciences as well. Because if you go to uni, even if you go to uni and do chemistry, you won't use math method. So this would be like if we were talking about 10A, this would be probably the second or third video in the sequence. I'll number them so they're in order. So we have to upload at different times. So was that 1.445, Henry?
Yeah.
So we have, well, our next line would be, so what do we do? We have 1 plus I to the power of 8 equals 1.445. So how will we remove the power of 8 here?
You get the 8th root of I plus 1.
So we take the 8th root, the 8th root. So that would give us 1 point, or if you want to calculate that, Henry, if you calculate. So 1 plus interest equals 1.0170 something.
I'm just calculating it. Like 1.0470887195.
Okay, so we just take 1 away from that because the initial equation was 1 plus I, and that gives us our interest rate. So I was explaining Henry and everybody watching the recording, Finn, that the one thing I noticed, especially in chemistry, is that you get students doing methods, but they forget how to do algebra. So we're going to go through that. It'll be part of sort of 10A revision. So I'm not, you guys aren't doing senior chemistry yet. Some of you might be actually grade 11. So the formula itself won't mean much to you. But it's not about the formula, it's about So you get into grade 9 and 10, you're expected to rearrange, or single swap equations. Get into grade 11 and so all of a sudden you've got 5, 6, 7, 10 variables that you need to solve for. Don't worry about the formula or what any of the coefficients mean. How would I solve for n? How would I rearrange this equation to solve for n?
Take R and T on the other side.
So we do a straight swap. Oh, wow, that's wrong. What did we do then? Don't think too much. So what's the inverse of multiplication?
Division.
So we just have n equals PV over RT. What if I wanted to solve for V? So now I'm solving for V.
You make that like PV over P, and then you have to do it to the other side too.
Yep, so you divide both sides by P.
Yeah.
So you have V equals nRT over P. Man, these pens crap. What else? What about if I wanted to solve for P?
We just get P equals nRT over V.
Okay. What if I wanted to solve for T?
Get PV over NR.
T equals PV over NR.
Yep.
All right. Well done. You guys are much better than my 10A maths class. All right. I was expecting that to take longer. What else? What other equations? Are there any other equations you have used in science that we can play around with?
No, not really. I sue that in physics, but doesn't really. Yeah, I'm not doing physics, so yeah.
Should we do F equals MA? I'm sure you'll be able to figure that out. I'm going to make it more and more complicated. So what could be if we wanted to solve for maths?
It would just be F force divided by A.
Yep. So you divide both sides. All right. Hopefully this kicks the difficulty up for you a bit. Do I know the kinetic energy formula? EK equals, what's the kinetic energy formula? Half mass volume squared. So how would I solve for V? This is getting a bit more methody now. We've got 2 minutes.
First, you take the half onto the other side, and then you put mv squared over m. M's crossed out, so then you've got 1/2 ek over m.
So I'll step you through how I did it earlier when I was playing around with this. So we've got, I don't know why I can't see the initial equation. So kinetic energy mass, half mass. So I get rid of the half first. So I times both sides by 2. So I have 2 EK equals MV squared. Remember, I'm wanting to solve for V. What would be my next step?
You do the square root to get rid of the squared.
Probably times M, but divide both sides by M first.
Oh yeah, but yes. Sorry,
Yeah.
you do the M and then you do the square root.
So I'm just trying to be methodical in the step through. Trying to be. So we have 2A, 2EK over M equals. How do we get rid of V to the power of 2?
Squared root.
Take the square root. All right. You guys are doing much better than my 10As. That's okay. What schools do you go to?
Matthew Flinders.
Yeah, that's right. You go to Matthew Flinders. Your mom's a teacher there.
Good Shepherd.
All right. Here's one. So have they, in the finance stuff, do they take you through present value and future value, Henry?
We haven't done too much finance, but I think we did it at the start of the year, but I can't remember it.
It's all been a bit up in the air this year with the grade 11 stuff, with what happened last year. So the formula for future value, the test bar, of money, of any kind of money, one plus so the future value of money in an account gives us the present value or the amount of money. We'll use a bank account as a nice, easy one. The interest rate as a decimal. So this is like sort of a mini intro into exponentials. This is kind of an exponential equation, but kind of not. Oh, that's just one. So. Oh, hi, Kat, go away. N being, in this case, the number of compounding periods. So what kind of graph shape are you going to get with this? Or what? Are we going to have an exponential function or a linear function?
A parabola.
Shouldn't get a parabola. Yeah, parabola. So we put $10 into a bank account. And every month we get 1% interest. Is that gonna go up in a linear fashion if we're compounding it?
Yeah, it's going to be linear. I was just
It would be linear if the interest.
No, it's not going to be linear because it's compound interest.
Yeah, if it was
It's gonna be
simple
an
interest.
exponential function.
If it was simple interest, I wouldn't go off 0. It would look something like that, right? Nice and straight every single time. So we're looking for. It's not quite. It'll probably take a very long time to go vertical. So to figure out future value, we're looking at an exponential increase eventually. Be nice and slow at the beginning. Here's a little bit of critical thinking for you. How would I go from future value to present value? It's a very, very small change. So to figure out the future value, we need to see where it ends up. what very tiny change could we make to this equation to solve for the present value when given the future value? Got 2 minutes to have a think. If to figure out this is power of positive n, how could we possibly go the other way? I think I probably just gave it away.
Negative interest. Or you just negative, put it to a negative power.
Yeah. So we would rewrite the formula as present value because what that's going to do is every time we're looking at an n or period, a compounding period, whether it be a year, a month, day, second, whatever, it's now going back that way, in that direction. Sorry, I should clarify. All right. I did this similar thing with my class and they were not this good as you guys. Does that make sense with the power to the power of negative n?
Yeah.
You will do a lot of financial maths we're supposed to in grade 11. For the grade 10s, this is more about formulas and rewriting and solving for unknown quantities. Again, probably good revision for you guys. I'm just putting it in as a video in the sequence. Okay. Okay, this one. So I'm concentrating on the financial math stuff, but this stuff applies across the board, especially if you go into the science. So reducing balance loans is when you're making a repayment and the bank is charging you interest each month. The formula for this, do not quote me on this formula. AR to the power of n so that's the formula that we would use to calculate the monthly repayments. So I'm going to give it to you in a context of answering a question. So someone's borrowed $80,000. You've got monthly repayments. What's the interest rate going to be? %11.7%. So how could we use that formula? And the loan term is 12 years. Oh, wait. And it's compounded monthly repayments and compound. So I think understanding the formula and then being able to rearrange it. So you've got your calculator there, sub the numbers in, use the formula, and then we're going to use the formula to solve for unknown, like we have been doing. Let me know once you got the answer. It's more about just using the formula than getting the answer right. Just to clarify. So we'd have 80,000. Always, so when you're calculating interest, you divide the interest rate 0.0117. You're dividing it by 12 because we have monthly compounding periods. So we have 0.0000000975. R would be, and to the power of 144. We then got 1.01 minus 1 divided by, anybody manage to calculate the answer? Your calculator.
My calculator's too small.
The calculator is too small.
Because my graphics are in school, so I'm just using like a pocket.
Ah, okay. I'll put that into my calculator now. 1036. So 1036.25. So this is the easiest thing to do. This is telling us the monthly repayment, nice and easy. We can also calculate how long it takes. Actually, no, we can calculate the repayments and how long, or let me rephrase well, my brain's working really well. If we're making fortnightly repayments, we can calculate the balance of the loan after a certain number of years. If we know the interest rate, how much is being borrowed, that kind of thing. And I think we'll finish there. So I'm going to make this into like a sequence of like 15 videos. This would probably be like number 3. So basics of rearranging and a little bit of financial math. So sticking in the 10A kind of region. So I've borrowed 55,000. And each video, some of the stuff we've got up into grade 11 for, so like the sequences, a little bit of financial maths as well. The rest will be likely 10A. Because most of the stuff you do in grade 11 is just an extension of what you do in grade 10A. Okay, 7.8%. And there's a little bit of carryover between year 12 general and year 11 methods, which are finance, so financial maths as well. And that's where you blur the line with the exponential versus linear stuff. So 55,000, 7.8%. Fortnightly repayments of $430. And I want to know the balance after 2 years. We've got what? Fortnightly repayments. And I want you to use this because the homework I'm going to set for Wednesday is solving for an unknown part of this equation. Just the actual, just subbing the numbers in, that shouldn't be too difficult for you. But I want you to rearrange loads of different equations. So the balance at n number of compounding periods equals AR to the power of n minus Q, which is the balance, divided by the rate minus 1. So Bn is going to be B52. It's not going to be 2 years. It's not going to be 2, but you've got 26 compounding periods over 2 years, which gives us 52. A is going to be 55,000 to the power of 52. Q is going to be your balance. Sorry, Q is going to be your repayments, not your balance. And you just sub in your interest rates there. Nice and easy. What I want you guys to do is solve for R, which is your interest rate plus 1. And I know we did that with the other formula, but this one is slightly different. So between now and Wednesday, so I'm making these around the 30 to 35 minute mark, I want you guys to figure out how to solve for R. There's a couple of them, it's a little bit more complicated. Actually, I'll have to spend the next couple of days figuring it out along with you guys. And then on Wednesday night, the first part we'll go through is this. Is there anything in particular that either of you guys want to go through on Wednesday? Is there anything in particular struggling with?
I don't have anything because we're just doing derivative, which is easy.
Yeah. Okay. Finn, anything in particular?
Not really, not at the moment, no.
No, that's fine. I'll sort of write out the sequence, and anything we're missing, even if we'll go back a little bit to move forward. So I'll do 2 recordings this week, I think, like I said in the beginning, 3 next week, and then a few over the holidays, which should make it about 10 hours worth of content, and we'll sort of make it a sequence from 10A moving all the way through 11. And I will see you guys on Wednesday. So it was originally meant to be 1 hour sessions, 10 of them, but I figure if we do 15, 16, 35 to 40 minute sessions, I think probably get a lot more out of it than trying to sit there at 8 o'clock at night doing an hour of methods and maths. So you get the same amount of content, just spread out a little bit more. All right, I will see you guys on Wednesday.
Thanks, Liam.
See you, Henry.
Yeah.
Cheers, Liam.
See you, Finn. See you on
Have a good
Wednesday.
one.